And on page 13, you see a title that says parallel and perpendicular lines. So we're going to be looking at an equation, and they're going to be asking you to write another equation that is parallel to this equation. So they're going to give you a point, and they say, I want you to write in slope-intercept form some equation that's parallel to this one, but will also go through this particular point. So it can't be like any parallel line. It has to be a specific parallel line because it has to go through this point right here. Okay, so what I'm going to ask that you do is have out your graphing calculators, hit your y equals key, and in the y equals key, I just want you to put in several equations. So if there's already something in the y1, the y2, and the y3, just go ahead and delete that. Okay, clear that out. And then in the first one, I want you to put y equals to 2x. So just put 2x in the y sub 1, and then put 2x plus 4 in the y sub 2, and put 2x plus 6 in the y sub 3. So you should have 2x in the first line, 2x plus 4 in the second line, and 2x plus 6 in the third line. Now, hit graph. Okay. Now, when you hit graph, you should see 3 parallel lines. Is that true? Okay, you should see 3 parallel lines. Now, going back to the y equals key, where I asked you to put in 2x and 2x plus 4 and 2x plus 6, what do you notice about all of these equations? What's the slope? 2. So basically, I could say 2x plus anything. As long as I keep saying 2x, the lines are going to be parallel to each other. Okay, so what I wanted you to get out of that little demonstration is that parallel lines will always have the same slope. So we're going to write that note at the top. Okay, parallel lines always have the same slope. Okay. And that's going to be important because when we do perpendicular lines, the slope is going to be different. And I'll show you how you determine the slope for a perpendicular line. But for a parallel line, if it says the word parallel, then you know it's going to have the same slope. So I already know that I'm looking for an equation, another line that's parallel to this, which means it has to have the slope of 1/2. So what you are getting from this information that they give you, because they're just going to give you an equation, the reason they give you the equation is because they want you to identify the same slope because they're parallel. Okay, this number right here doesn't even matter what that number is. That is not why they're giving it to you. They're giving you this equation because you have to get the slope. Now that you have a point, here's your point. So now that you have a point and you know the slope, we're going to put this in point slope form, even though it says I'm trying to get to slope intercept form. Okay, so when you have a point and a slope, always start with point slope form. No matter what form they're trying to get you to, with the information you're given, you want to put this in point slope form. So let's go ahead and do that. Now recall point slope form, y minus y sub 1 equals the slope number times x minus x of 1. Okay, that is point slope form. So I'm going to just put my numbers in the proper places. So y minus 5, that comes from the y coordinate, equals my slope number, which is 1/2, times x minus 4, which is the x coordinate to the point. Okay, so once you have it in point slope form, it's very easy now to convert it to slope intercept form. Okay, then it's also very easy to convert it to standard form if I had asked you to put it in standard form. Okay, so let's go ahead and distribute this out. So y minus 5 equals 1/2 x minus 2 And then once I add 5 to both sides, I get 1/2 x plus 3. And now I have it in slope-intercept form. Okay. All right, any questions on that example there? Okay, so let me ask a question. So what was the purpose of them giving you this equation? Who can tell me? Why did they tell you that it's parallel to y equals 1/2 x plus 2? Yes. For the slope, exactly. For the slope only. Doesn't even matter about this plus 2, but it was definitely just so you can know you're using the same slope, right? Now, you could check this on your calculator. So everybody hit your y equals key. Type in the answer, 1/2 x plus 3. Okay, then when you go to the table, you're going to hit second graph. You know how to get to the table. You should see that 0.45 in the table. And that's how you can make sure your answer is correct. Okay, because it says it has to pass through this point. So that point must be in the table. So if you're taking a test, or if you're taking you're going to do your math assessment thing in a minute, if you're taking something like that and you want to see if your answer's right, you can just simply type it in, see if that point's in the table, you know you're correct. All right. So we're going to do another parallel because this one says perpendicular. So let's go down to question number 3. Okay. All right. So in question number 3, it says it has to go through this point here, 4, 2, and it's parallel to this equation, y equals negative 1/2 x minus 5. Okay. So my slope is going to be negative 1/2 because if they're parallel, they have the same slope. So what form did I say we would put it in? Point slope form. So we're going to say y minus 2 equals negative 1/2 times x minus 4. Okay, just drop the numbers where they go for point slope. Now let's go ahead and solve it for y because our goal is to get it in slope-intercept form. So negative 1/2 x. Be careful right here. What is a negative times a negative? So that's a positive 2. And then when I solve for y, I just add 2 to both sides. So I'm going to have y equals negative 1/2 x plus 4. Okay. So it's pretty basic. And once you do it in point slope form and solve for y, you're done. Okay. All right, we're going to do one more parallel and then we're going to get to perpendicular. All right, so what's my slope I'm using in number 5? 2. Very good. So now we're ready to put it into point slope. So y minus 4 equals 2 times x minus 1. So y minus 4 equals 2x minus 2. Okay, because we're distributing. And then we add 4 to both sides. So y equals 2x plus 2. And again, if you wanted to check, you could hit your y equals key and make sure 1, 4 is in the table. So for perpendicular, there's a different rule that you follow to get the slope. So you're going to need to write this rule down as well. Okay. And let me give you the symbol, because there is a symbol for parallel. This is the parallel symbol. Let you know because you'll need to know this later. It just looks like 2 lines, okay, or 2 lowercase l's. Okay. For perpendicular, there's also a similar symbol. And it looks like an upside down T. Okay, so that's the symbol for perpendicular. Now, to get the slope for perpendicular is different from parallel. So that's why now you're going to have to pay attention to these words. So we're not using the same slope. What you're going to do is you're going to use the opposite sign. Okay, so I'm going to say slope equals the opposite sign. So that means if it's negative, it becomes positive. If it's positive in the problem, it becomes negative. And you got to make 2 changes. Reciprocal. Okay, for reciprocal simply means you reverse the numerator and denominator. Okay, so let's look at 1/2. So I know the opposite of a positive 1/2 is negative 1/2, and I have to flip it. So if I flip negative 1/2, I'm going to get negative what? -2, and I don't need to say -2/1. Okay, so what I did was I took the opposite sign of the positive number, it got negative, and then I reversed the numerator and denominator, and that's a -2. So this is the slope you're going to use for perpendicular. And then we just follow the same process. We put it in point slope form and solve for y. So once you get the correct slope, you're ready to go. So y minus 5 equals -2 times x minus 4. And then we follow that same process, distribute, and solve for y. So -2x plus 8. Then we're going to add 5. So that's -2x plus 13. And again, if I wanted to check this, then I could just type it in and make sure 4 or 5 is in the table. Now, when two lines are perpendicular, that means when they intersect, they form a 90-degree angle. Okay, you guys know that parallel lines never intersect, right? All right, looks like they want to do a whole lot of 1/2s and 2s, but anyway, let's go ahead and do number 4. So who can give me the correct slope to use since it's perpendicular? Okay, go ahead. Oh, yes. Very good. So that's going to be a +2. So opposite side will be positive, and then reverse it. That means take the reciprocal. It's going to be a +2. Okay, let's write it into point slope. Y minus 2 equals 2 times x minus 4. And then we're going to distribute and solve for y. Okay, does that seem pretty easy? Because once you get the slope, you guys already know point slope form, so it's not like that part is new. You just, get your slope from the problem and then keep going with your point slope and slope intercept. And like I said, it's easy, very easy to go from point slope to any other form. And remember, you cannot go directly to standard form anyway. So if I had asked you to do it in standard form, you still would have to do point slope form first. Okay, because you can't go directly to standard form. Okay. All right, let's do 6 and then we'll be done with our notes. Okay, so here's another 2. So the opposite of that will be negative, and then when I reverse this, it's going to be -1/2. Is that correct? Yes, so y minus 4 equals -1/2 times x minus 1. And then we'll distribute. Y minus 4 equals -1/2 x, and this is going to change to +1/2. Add 4 to both sides. So y equals -1/2 x plus 4.5, which is the same thing as 9/2. All right, so that is the lesson for parallel and perpendicular.